4 with the balance block team. This is Chris Hamrock, Stefan Verna, Nicole Beck, and I'm Stephanie Kozek. Before we begin, I just want to mention that for our project, we kind of wanted to focus more on the basics. We built a lot of our own modules. Instead of buying Saber 2, the motion motor controller, instead of buying a wireless remote or the wireless comm, we built it. We just kind of wanted to show that we could utilize all the different things that we've learned in our classes at the university. You know, some other projects didn't do this, but that's because we kind of chose a different project. We chose a project that allowed us the time and the ability to do so.
Okay, when we were just looking for a project, we came upon this Robo Games. We came upon the balance ball, which is a 1 or 2 wheel robot that has to balance on its own and controlled by remote control, which are standard vehicles and objectives. Our constraints are that the robot must be designed in such a way that it doesn't weigh 50 pounds, and the size doesn't exceed 3 foot cubed, and it cannot use an internal or external combustion. Okay, here's a hardware block diagram for the remote control. The remote control is powered by a 9-volt battery, which goes through a DC-DC converter, which converts the voltage to 5 volts, which powers a joystick, the remote control unit, which is a PIC-18, and a wireless transceiver. The remote control gets the driver outputs from the joystick and sends the driver outputs and an e-stop output to the wireless transceiver. Which on the other end, on the balance block diagram, the wireless transceiver receives those driver inputs and e-stop inputs and sends it to the balance control unit. We also have 2 batteries controlling the balance block. We have one battery that supplies minus 12 volts. We have another battery that supplies plus 12 volts. And it goes through 2 converters, a 5-volt converter, a 3-volt converter, which with 12 volts, 5 volts, and 3 volts power the robot.
Alright, now the wireless transceiver talks to the balance control unit, which there are 3 microprocessors on our robot, and the balance control unit is like the master of all of them. So it controls, the main goal of it is to balance the robot. So it gets feedback from the sensor control unit of the angle of the robot. So if it starts tipping one way, it will know that it's starting to become unbalanced and needs to drive the motors in order to rebalance itself. And the sensor control unit will get the angle from the ultrasonic distance sensors, which are on the other side of the robot pointing down towards the ground. And that distance is converted into an angle and sent to the balance control unit every 10 milliseconds.
All the blocks in red are for the motor control unit. Basically, the motor control unit is what's going to control, well, it's going to drive the motors forward and backwards and make it turn, and it's also controlling the torque to keep it balanced. It's made up, there's an H bridge for each wheel, and so basically the motor control unit is going to send a voltage to the driver circuit, which is BJTs, which are going to drive the effects of the H bridge. And then it's going to drive whichever way the current's going to go through the H bridge is which way the wheels are going to turn, so we can forward or backwards. And then you can see to the right of each H bridge is the current sense circuit. It's made up of a current sense resistor and a current sense amplifier. And the current sense resistor is a known resistive value, which is 0.01 ohms. And that's basically used to find the voltage at that point. That voltage is then amplified so that it can be right by the PIC of the motor control unit. And that way, because voltage is proportional to current, and we know, since we know the voltage of the current sense resistor, we know the current of the current sense resistor, and that way we find the torque that we need to keep the platform balanced.
This is a software block diagram for our system. I'm the computer engineer on the team and did the software. At the top level, it seems fairly simple, but coordinating 3 microprocessors, the main one being the balance controller, running at a 10 millisecond loop isn't always the easiest thing to do. You start with the sensor control unit. It's constantly pulling the ultrasonic sensors. We get about 4 readings per 10 millisecond interval. It constantly reads those